Here's lesson 115, number 6. It says use the polynomial equation and a divisor of x plus 2 to do a specific development of the remainder theorem by showing that the remainder equals f of negative 2. So in other words, when you divide the polynomial, when you do the division here, the remainder is going to be the exact same number as you would have got if you would have just plugged in negative 2 everywhere for x. Okay, so how do we show that? Do our synthetic division. So all these numbers just came off the coefficients of that cubic that we started with. And I'm going to divide by negative 2. So there I'm just showing my synthetic division. You'll notice I got a remainder of negative 50. So then I can rewrite that at, yeah, it's supposed to be x plus 2. Number 6. Yeah. Okay, so rewrite it as, now where did this come from? It came from these numbers. So I started out with a cubic, but since I divided out 1 degree, then now it's a quadratic. So 3x squared negative 15x, 27. And then I just left the minus 50 hanging off the end because that's like a remainder. Okay, then I set that equal to the original polynomial. Now I'm going to plug in negative 2. Because that's what we're trying to prove, is that if I plug in negative 2 into the original polynomial, I should get this. Okay, so if I plug in negative 2 here, that gives me negative 8 times 3. There's where my negative 24 came from. And that gave me a 4 times 9, 36. 6. Basically just plugged in negative 2, I ended up with negative 50. So to me that already proves it, but we're showing it. So this is the factored form, and if you can see, if I plug a negative 2 in here, this thing right here is going to zero out. And I'm not even going to waste my time plugging the negative 2 in here, because whatever number this happens to be, when it multiplies against 0, it's going to zero out. And I'm going to get negative 50. So there's my development.